We have started with the concept, or we have started studying the contract documents, and there are mainly three things which you want to focus on: drawings, specifications, and BOQ. We have talked about all of them briefly in the first lecture as well, in the first set of slides. And drawings, they give you the measurements of every item in your project, okay? And it's our job as a quantity surveyor to examine the drawing, and we have to identify which items we can measure on the site and how would we measure them. If there are any problems or discrepancies, we have to report and we have to get it corrected before the project is executed. These drawings, or the set of drawings, include these items: cover page, specifications. I told you they are separate, but they are given with the drawings. And then we have plans, elevations, sections, and details. So cover page gives you the information about the project as well as the parties who are involved in the project. A specification tells you about what to do and what quality you are expecting, okay? And for quantity surveyor, it helps you to get the price accurate, okay? Without the correct specification, your pricing will be very very erratic or very inaccurate. These are the specifications. You can see lots of details. The plans, top view, and they help you to calculate the area measurements, the quantities of concrete and excavation and so on. Elevations help you to get the finishing works, the quantity of the finishing works, paint, plaster, windows, doors, and so on. Details, they are very important to calculate the quantity of steel or anything, or pipe works, maybe any installation which you are doing inside the structure, okay? To do the pricing for that, you need the details. And a very important part of the details, or the part on which we focus on these drawings, are the connections, okay? Where the beam is meeting the column is meeting the footing. These connections are focused in the details. And then we have the foundations. So you can have a foundation plan which tells you where are the foundations, how many are they, what are their sizes, and so on and so forth. Then you have foundation details. So again, we are focusing on the connection of the beam, wall beam, column, and the foundation. You can see two connections in one drawing. You can see the reinforcement, the steel, the concrete size, okay, and how much elevation we are going down, and so on and so forth. So excavation can also be taken from here. Some actual pictures of the foundations, because they can be of different types. And we have looked at this example where we have looked at the concept. If you are so this is basically emphasizing the importance of specifications, okay? So when you change the specification, complete pricing will change, your BOQ will completely change, okay? So if you go for the first scenario, no reinforcement, low quality concrete, your BOQ will look like the first item only, okay? And for the second case, if you have good quality concrete and you are putting fiber reinforcement as well, then it will look like the second item. So you can see one whole item is increased here. And when you will put it with the rates, again, these things will change. Okay. Now this is an item which is showing the column and the floor, or the roof slab. Okay, so this is the column, okay, and then you have the basement floor and you have the ground floor slab, okay. So from the specification, it says that all internal walls must be 100 millimeter lightweight block work. So not the column, sorry, then this is the wall, okay, so this is the wall. Now you look at the drawing and the specification, you tell me the problem here. What's the problem here? Yes. Okay, so there is a discrepancy between the specification and the dimension of the wall. Okay, so which one do you take? Huh?
What's given in the specifications?
What's given in the specification? Hmm? Which one? 100 or 200? 200? You are saying 100, right? You are saying 200. Why don't you guys fight and whoever wins will go with it?
It says shall be one.
Yes. Which one? 100, 200? Huh? 100? Same what? 100? 100? 100? Because it is written, right? Because it is written. Huh? And why you are saying 200? All of them are against you. What's your name? Huh? Yeah.
Because it's on the details.
Because on the drawing. Why the specification say 100? Maybe the person who was making the specification of someone like to copy and paste. Can happen. But the problem is we are not sure. Now there are two things and they are different. Okay? We cannot assume this one is correct and this one is correct. We have to check. Okay? So the correct procedure as a quantity surveyor, obviously if you are the consulting engineer yourself, then you will correct your mistake. This is your mistake. You will correct it. Okay? Or you are the architect and you are supposed to find out the thickness of the wall. You will correct it yourself. But we are looking from the point of view of the quantity surveyor. If you are the quantity surveyor, okay, you cannot assume, I did not design this wall. I am not the architect. I am not the design engineer. So what would I do? I will go back to the person who made this, who designed this, not made this, who designed this. Okay? So 100 could be correct, 200 could be correct. I am not sure. Okay? So assumption is not an option here. Assumption is not an option. You go with this one or that one. Okay? So you will, the problem is there are two different numbers in two different sources and we have to report it to the client and the consultant. Okay? If the client already gave you these things and he is asking for tender price, okay, that now I have to put the tender for the contractors, give me the price for this. So you will not proceed with the pricing because of this. The price of 100 millimeter block is different than the price of 200 millimeter block. Okay, so you cannot give the price. So what we do, we file up, if you are part of the project, there is a document, a form, a template, which we file to the client or the consultant, which is called as request for information. If you are from the contractor side. So the client gave you these drawings and specifications. Now he is asking you, what will be your quote? What will be your quotation? Okay, so you don't make your quotation. What you will do, because of this problem, you will go back to the client, you will fill up a form which is called as request for information, and you can give it to the client or the consultant, whoever is dealing with you. And until you get this information clean and clear, you will not go ahead with the pricing. Clear? Okay. Any questions? Okay. Okay. Now moving on, the first thing which we do in construction projects. So while we are going through this course, you will see that we will be going through the activities which are involved in construction. Because until and unless you know about these activities, you cannot do the pricing. Okay? So we have to look at these activities. The first activity is what? Excavation. Because it is written, right? It's wrong. The first activity is ground preparation, okay, site clearance. Okay, but anyways, the first sort of a drawing which you may get, ground clearance is general. Like you start the site, you have to do the ground clearance. Okay, unless something is already there. If it's an open area, you have to do the ground clearance. There may be some plants there, some soil there. Okay, I heard in the news people are leaving their cars. Like they just leave it there, and the police are doing some actions against them. Did you see the news? No? So, seems that you guys have a lot of cars and you can just leave them around. You know, old cars now you don't want to, they are not working and you are just leave them. Okay? So, anyways, so the ground clearance is the first part, okay, but the first drawing which you will get and the first set of calculations which you will do is for the excavation, okay. So the shade, so this is what an excavation plan may look like, okay. The shaded area is the excavation part, and what is this? The outer area represents what? I will do the excavation here. And what is this? What is the unshaded area?
The project area.
The full plot area. Okay, the project or the full plot area. So you may not be doing the excavation for the full plot. Okay, if your plot is 30 by 50 meters, you will excavate a part of it. Okay, so a shaded area is a part of the excavation, and when you will give this sort of an excavation plan to the contractor, you will mention the level which you want to have. Okay, after excavation. After excavation, what ground level am I looking for? Okay, so and you have taken surveying, right? Huh? So, for example, if I tell that I need the ground to be 1 meter after excavation, plus 1 meter after excavation, plus 1 meter from what?
Sea level.
Huh?
Sea level.
Sea level? Sea level?
Benchmark.
Benchmark? Yes. Okay. All of you are sort of correct. Okay. In many cases, sea level is our benchmark, but in small construction projects, it can be other thing else. It can be the road level. Anything which is known and fixed, and it will not be disturbed by your project. Okay. You can even create your own benchmark as well, that this is my level, and I will measure everything from here. Okay, this can be done. So you know that minus means you are going down and plus means you are going up. Okay, it can be both ways. So excavation level minus 4.62 means that maybe you have taken the road level. In most of the cases, we take the road level as our benchmark, as I already mentioned. So minus 4.62 means after excavation, the final level should be 4.62 meters from the road. Okay, so a very small set of calculations. Now, by the way, today we will do some calculations. Okay, but there is a standard method of writing them. We have not seen it yet. Okay, but just for the sake of practice, we will do some calculations. Okay, but they have nothing to do with the standard method of writing. Okay, so when you do these calculations, there is a standard method by which you write it. Okay. So this is our plot, 20 by 20 meters. The desired final level is minus 1.5 meters across the entire site. Okay, so from this point to that point, I want the whole site to be minus 1.5 meter after the excavation, same level. Okay, this could be because I am laying out a slab. It could be because it's for road works or tunneling or something like this. Okay, because for buildings normally this is not done. Or maybe I'm using a type of foundation which is I forgot the exact name, but like you have a foundation which is a combined foundation for the entire building. Okay, so we have isolated foundations when we have these raft or combined foundations. Okay, so maybe it is one of those cases. Okay, I will show you the other case as well. Okay, in which you calculate the excavation for each foundation, for each footing. Okay, but in this case, excavation level is the same. Okay, ground level is the same. The dimensions, the levels are taken at each corner of this plot. Okay, so on the four corners they have taken the dimensions or the levels. Sorry, the levels. Now this is enough if the plot is smaller and the difference is less. Okay, now you can see here. The difference is not so much. Okay, and the plot is smaller, 20 by 20 meters. It's a relatively small plot. Clear? But if you're doing it for a road work and your road is 2 kilometers, so you will not take one level at 0 and the other one after 2 kilometers. It's too much. Okay, or you were taking the levels and you found one level to be 0, the other one is -5. You can see a difference now. Okay, so if the plot is bigger or the difference is too high, then you have to take more observations. Okay, and then we can apply another method for calculating the excavation as well. But right now our plot is smaller. Okay, and the difference is relatively low, so 4 corners are enough. Okay, so it's a relatively easy example which will not come in the exam, right? Only to make you happy in the class. Okay, so we have to find out the area of excavation. It could be area of cut or fill. You know the meaning of cut or fill? What? What? Cut means what?
Cut means I have to remove.
You have to remove, and fill means you have to fill. Okay, so you already have the idea, right? Okay, so because the levels are changing, it could be cut, it could be fill. So it may not be excavation all the time. If it's a fill area, it's not excavation. Okay. First thing we will do is we will find out the average existing level. In this case, a small plot, little difference. We'll go with the easier approach, find out the average existing level. Okay, you have the 4 values. What is the average? Tell me. Yes. Hmm?
Average of the 4 numbers.
Yeah.
1.45.
Huh? What?
1.45.
1.45. Okay. Minus, right? Minus. Okay. Now, what do we want? What do we want? The level?
1.5.
1.5, right? Okay, we have minus 1.45 and we want minus 1.5. So what are we doing? Cutting or filling?
You have to fill 0.05.
Fill. What are we doing?
We have
I'm not even looking at you guys. Why are you speaking? Shh. Yes. Cutting or filling? Huh? Filling? Filling? How can you all be wrong at the same time? Like, you guys are X-Men or something, right? You communicate. Huh? Like there are 2 answers. Huh?
should be cut. 0.05.
Why? Who goes now? Professor X?
No, it's bigger than minus 1.5.
See, yeah, you have minus 1.45, right? And you want minus 1.05, minus 1.5. Okay, so minus 1.45 is higher, minus 1.5 is lower. Got my point? Clear? Okay, so yeah, we will do the cutting here. Okay, so it will be, yeah. So minus 1.5, which we want. I don't know how to write it. Okay, minus 1.45 we have. Yeah, it will be minus, sorry. Okay, so if you write it in this way and you get a minus in the answer, that means you are doing cutting. Okay, so it's an easier way to remember. Huh? You don't have to use your brains. Very happy. No, I don't have to use my brain. Thank God. I will save it for the judgment day. Okay, clear? Okay, so this is the depth which we are looking for. Okay, but how much is my excavation volume? Now tell me.
It's 1.5.
1.5? Excavation volume.
0.004.
Yes.
0.004.
400. And what is 400? Area of the plot. Okay, so you on average you need to do a excavation of 0.05 meters. Okay, or means what? 50 millimeters. 0.05 is 50 millimeters or 5.
0.5.
Yeah, 50 millimeters, right? 50 millimeters. So 50 millimeters, and the area size is 20 by 20, which is 400. Okay, so it will be 0.05 into 20 into 20. 20 cubic meters. Okay, a very simple method. Okay, you are just finding out the average difference, because on the side it's impossible. Even if I give you more values, it is impossible to get the exact amount of excavation. So we are always working on the average values, because the ground level is never flat. The natural ground is never flat, no matter what the elevation is. Okay. So in the end, you will be working on average values. There's another method in one of the books, which is called the grid method. You can find it online as well. But the one or two of the books have this method as well, which is called the grid method. Maybe you use it in surveying for something else, for area calculation, something like this. Okay, or maybe in contouring you have used it. So in grid method, they will give you more elevations. So instead of having a block of 4 points, you will make a grid, and each intersection point you will have an elevation. Okay, so then you will have more elevations, more values to calculate the average. Okay, but even if with more values, it's an average. Between the grids, it's an average. Okay, so if I have grids after every 1 meter, okay, so after every 1 meter I will give you elevation. But what is happening between 1 meters? Average. Right? Get my point? So there are some quantities where it is impossible to take the exact value. Okay, we can make it more accurate, but in the end it's a more closer average. Okay, then we have the beam framing plan. You may have made it, you definitely would have made it in the drawing course. Okay, 160. So you're looking at the slab at the level of the beam. Okay, you are looking from the top at the plan view at the level of the beam. Okay, so the beam plan will show you the beams as well as the columns. Okay, and normally we assign codes to all the beams. Okay, and if they are similar, they can have the same code. Okay, so you see these small dots here, they are basically codes: B1, B2, B3, B4, something like this. Okay, and why do we have these codes? So that we can make something like a table to show the details of the beams. Okay, so I know this one is B1, for example, and this is my beam detail or beam schedule. Okay, so I'll go here, I will look for B1, and this table will tell me the height of the beam, the depth of the beam, the length of the beam, the enforcement in the beam, and so on and so forth. Clear? Okay, so the coding is done for that. To highlight the details of inside the beam, we make not here, where? It's not here. Okay, but we cut the section, then we make the details drawing. Okay, we make the details so that we can see what is happening inside the beam. Okay, how the bars are placed and how the stirrups are and so on. Okay, but again, some of the or all the details are given in the beam schedule as well, and the beam schedule is coded according to the codes which are given to the beams. Okay, and similar beams can have the same code. Okay, yeah, so here you can see the beam cross sections. Okay, so we have the longitudinal section and we have the cross section. Okay, so longitudinal section shows you the stirrups, the top bar, the bottom bar, full length. Okay, how much you are giving these bends. Okay, at what point we have the extra bar. Okay, and so on and so forth. Okay, sometimes we put extra bars at the top or the bottom. Okay, so their location, their length, all these things are shown in the longitudinal section. Okay, and then we have the cross section, which basically tells you how these bars are placed. Okay, so at the bottom I have how many bars? 3 bars. At the top how many? 2. And how these 2 are placed? In the middle? No, they are at the corners, right? Okay, and how these 3 are placed? At the corner, 1 in the middle. Okay, and this can change as well. Okay, so and you can see the connection with the columns as well, the connection with the slab as well. Okay, they also mention the type of enforcement you have. Okay, so Y32, Y25 is a strength of steel. Okay, why it is called Y? Because steel has yield strength. There is something which we call as yield strength for steel. You have taken steel? No. Okay, but you have taken concrete design, structures. Anything about the structures? The structural design? No, nothing. Anyway, so when you are doing the design for steel, we use a strength which is called as the yield strength. Okay, so that's why the Y is there. Okay, so these are the details about the beams. Okay, so we have the main bars. The longitudinal bars are called the main bars, and then we have these rings which are called as the stirrups. Okay, so main bars are going along the length of the beam, and the stirrups are tying the main bars. Okay, so they act like a ring which holds all the bars together. Okay, so for the main bars we give the numbers: 2 main bars on the top, 3 main bars on the top, something like this. Okay, and then you measure the length and multiply with the number. Okay, for the stirrups, now you can see, if I want to count the main bars, it's easy: 1, 2, 3, 4, 5, 6. Okay, or 5. But if I want to count the stirrups, there are too many, right? So we don't give the number, we give their spacing. For stirrups, you will have the spacing. From spacing, you will calculate the number. Okay, if I have this much beam, this much length of the beam, and I have a stirrup after every 300 millimeters, so how many stirrups I will have? Okay, something like this. And then in the end, as I mentioned earlier, for all these bars, we will convert them into the weight. Okay, in the end, for steel bars, we need the weight of the bar, weight of steel. Okay, and normally in tons, because construction projects require a lot of steel. Okay, So for example, we look at this cross section, and again, this is, we are not going through the standard method of calculating, okay, we are just looking at how it is calculated. We are not writing it them down in the standard method. Okay, so we have a stirrup, okay, which one is a stirrup? The blue bar is a stirrup, okay. The diameter of the blue bar or the stirrup is 10 millimeters, which can also be represented by 5, 10, okay, so that means 10 millimeters. The spacing between the stirrups from one end to the other of the beam is 150 millimeters. So after every 150 millimeter there is a stirrup, okay, and this spacing is center to center. So stirrup diameter is included in that, okay. The length of the beam is 6000 millimeters, meaning 6 meters, okay. Now we will be using this length for calculating the number of stirrups, okay. So keep one thing in mind, I show you from this slide. Stirrups are given in the clear length, okay. So you can see there is a column here. Inside the connection of the beam and the column there will be no stirrup, okay. So if I say that I will use 6 meter length to calculate the number of stirrups, I'm using it from this face up to this face, okay. Inside the connection there is no stirrup, okay. Okay, first thing we will do, so the steps are written here, like I said, like I did earlier. First thing we will do is we will find out the dimension of the stirrup from inside to inside, okay. Now stirrup is a length, stirrup is a ring, okay. Whenever you provide steel inside concrete, you have to leave some gap between the edge of concrete and the steel, okay. There must be some gap between the edge of concrete and the steel. We call it concrete cover, okay, concrete cover, clear. If you don't leave enough gap, now remember, where is the load? On concrete, right? The load is on concrete, okay. If you don't leave this gap, because of the load there can be some cracks, and these cracks can directly go to the steel, okay. And leaving less gap will make concrete weak here, okay. So concrete in this section can be weaker because you did not leave enough gap, cover, okay. So leaving this cover is important to make the concrete strong, and to make sure if there is a crack, then anything which goes into the crack, moisture, water, sand, whatever, it will not go directly to the steel, okay. So we need to have some gap so that the bond is strong between steel and concrete, and the concrete does not become weak at the edges, okay, clear. So in order to calculate the inside length of the stirrup, okay, so first of all, this total length is 250 millimeters. The normal practice is at least 25 millimeter of gap is left on each side. How much? 25, okay. So 250, 25 from here, 25 from here. How many? Huh? 50, and the remaining is 200, okay. Okay, so 25 from here, 25 from here. You subtract for the cover, and the remaining is the length you need. This is horizontal length, and then we have the vertical as well, right? Okay, so again we will do the same thing. What is it?
Yeah.
500. 500. Okay, so doing the same thing, 500, 25 on the top, 25 at the bottom. You subtract it, you get how much? 450. Okay, so this is the inside length of the which we have available. Okay, so the perimeter of the stirrup will be this plus this plus this plus this, right? Okay, so 200, 450 for each side, multiply by 2, right? Okay, which is how much? How much? 1300. 1300. Okay. Now this ring will not hold if you don't provide these hooks here. Okay, it's like a knot. Okay, when you make a ring or when you make something circular, you have to tie it, right? Okay, so you have to make it like this. Okay, so this hook should be there. Normally the length of this hook for stirrups, okay, because stirrups are very thin, you can even see it in this picture as well. The bar is thick and the stirrups are thin, okay, because if you make them thick, then you cannot have them 300 millimeter spacing and so on. Okay, so what was I saying? Yeah, for these for these thin stirrups, the hook length is normally 9 times of the dia. And what is the dia? Huh? Diameter of the bar, yes. Okay, what is the diameter of the bar? 10. Okay, so yeah, it will be 90 for each hook, and there are 2 hooks, right? There are 2 hooks, so into 2. Okay, clear? No? Sure.
So total length is like
I keep on asking because I doubt some of you sleep with your eyes open, or your mind goes somewhere else.
the total length of the stirrup is 1300 plus 180.
Yes. Okay, so total will be 1300, which is just for the ring, and then plus these 2 hooks. Okay, and this is how much? 14. Okay. Now these stirrups are at how much spacing?
150.
Huh? 150 millimeter center to center, right? Okay. And how much length I have?
6000.
6000. How do I calculate number of stirrups now? Divide what by what?
6000 by 150.
The total length divide by the spacing, right? Are we done? Is this a number? No? Very good. Tell me. What are we missing?
The diameter of the stirrup.
Why you are doing this? Yeah.
Diameter of the stirrup.
Diameter of the, no. It's already center to center, diameter is like compensated. If I give you clear spacing than this. No. Hook length added, right? I'm calculating the number of stirrups. I'm calculating the number. Okay. So if I have length from here to here, okay, and the stirrups are at 150 millimeters center to center. So total length divided by spacing. Will it give you the number of stirrups? Now stirrups are starting from where?
It's going to be this
Huh?
this one.
25? No. 6,000 is the spacing from column face to column face. So 25 millimeters already done. 25 millimeters is done from the face of the beam. Okay, not the face of the column. Let me go back. Okay. So stirrup is from here. 25 millimeter I will leave from here for this bar. This is already done. Okay, for number of stirrups I don't have to do this. Okay, so from here to here. Okay, this is 6,000 millimeters. Between each 2 stirrups I have a spacing of 150. So we divided this whole thing by 150. Okay. What? Does it give you the number of stirrups? Why don't you? Yes. What is from that comes in the exam? Yes.
Yes, it gives.
It gives.
Yes.
See, he doesn't know as well. He says. When you divide something by the spacing, it gives you number of intervals, number of openings, not the number which you are looking for.
So I have
Okay, you
one.
get my point. Okay, so 6,000 divided by 150. Okay, or let me make it simpler. So, for example, if I say that my length is 2 meters, okay, and I will put the stirrups after every 1 meter, after every 1 meter, okay. So 2 meter divided by 1 meter gives you how much?
It's 2.
2.
2 intervals.
2. Yeah. Okay. So we cannot say it's number of stirrups because where are the stirrups? One here, one here, one after 1 meter, one at the
So
end.
you just
Okay.
have one.
So if you do 2 divided by spacing, you are missing the end. This will give you this. Okay. How many openings you have? Okay. So when you just divide by the spacing, it gives you how many openings you have, not the number which you want. For the number you have to. Okay. Clear?
I was about to say it.
Yeah. Thank God you didn't say it. Okay, this will give you the number. Understood? Any problem? Okay. Now I have these many stirrups, and one strap has a length of this much. So total will be okay. So what did we do? First of all, we calculated the perimeter of the strap, subtracted the cover from each side. Then we added the two hook lengths, 9 times of diameter. We added them all, we got the total length of one strap. Okay, then you divided the available length with the spacing of the strap. This will give you how many spacings you have. Plus 1 to get the last one, last strap. Okay, so this is what we did. So now I had number of straps, each strap this much length. What is the total length? Tell me.
60.680.
Huh? 680 what?
60.680 meter.
680 meters? Like this.
No. 68680.
68680 millimeters.
Yes.
Millimeters, right? Okay. Clear or not? Clear? Anybody? Any problem? Okay. Now we have the weight per unit length.
60, not 60.
Which one is 60?
60680.
Okay. And if you convert it to meters,
60.6.
okay, any problem? Is it clear? Okay. Now I will show you a chart. Okay, but I will tell you how did we calculate the length per meter. Okay, I will tell you how did we calculate the length per meter. So this is weight per unit length for a dia which is 10 millimeters. Okay, now if the dia is 10 millimeters, what is the area of the bar? Tell me. If the dia is 10 millimeters, what's the area of the bar? Yes, tell me. Give me a number. 714 what?
millimeter.
Square. Okay. So the area of this bar with a dia of 10 is 314. Okay, and how did we calculate it? How do we calculate the area of the bar? Area of a circle, for God's sake, please. Enough joking. Yes, area of a bar. Area of a circle. We don't know area of a circle.
2 pi r.
Huh? How does she know? She's from another planet? Come on, use your brains, okay? This is quantity estimation. If you don't know the area of circle, go back to school. Okay? Sorry? Yes. Okay. So, if you have a 10 millimeter bar, then the area will be this much. Okay? Then to calculate the weight per unit length, I'll use density. Okay? So density is mass per unit volume, right? Density is kilogram per cubic meters. Okay? So I will multiply this value with the density of this steel.
Yes.
Okay? Now if the weight is this much, I forgot the density, but you can check it online as well. If the weight is this much, how much was my density? How much is the density here?
Why is it 314?
What?
Why is it 314?
Because he said so.
It says
Nobody else is saying anything.
78.5 because the diameter and it's 2r. So we should divide it.
So how much is it?
78.5.
What are you doing?
Pi r squared.
Pi r squared.
5 squared.
Okay, and my R is 5. 10 is that, right? Now how much is this? How much is this?
78.5.
78.5. Okay, but this is in millimeters. Okay, so that's why, see, if there's a wrong answer here, it does not affect me. Okay, if you guys are relying on one person that he will keep on giving all the answers and we will just keep on moving. I will move along, obviously. I don't mind. Okay, but if you are just relying on one person, he will be wrong. Many times he will be wrong. You will get the wrong answer. I will move ahead. Okay, so it's good that you have to check. Okay, so this is in millimeter square. Okay, and how much in meter square? How much? Ten to the power minus
10 minus 5.
minus 5. Okay, so this is now in meter square. Okay, then you multiply with the density. Okay, and because this is area, not volume. Okay, this is area, not volume. Okay, and density is what? Mass per unit volume. You are multiplying only with the area, so you will get the answer in kilogram per meter. Okay, it will be weight per meter. So what density did I take here? I got the answer, I get this, and my answer was 0.617. So how much was my density? Steel density, as I said, you can just look at it on the internet, no problem. It's given in the books as well. Not a big issue. But just for the sake of this calculation, what was my density here? Tell me.
Just divide.
Tell me. Take the number. This divided by this, right?
Yes.
0.617 divided by this.
7,910.
7,900.
910.
910. Like this?
Yeah, 0.25.
0.25. Okay, this will be in kilogram, sorry, per meter cube. Wrong? How much?
75.
Yeah. How much is this? 7859. 10 to power what? Is there a 10 to power? 7859. Okay, this is like the approximate density of steel. Okay, now if I am using dia 8 bar or dia 16 bar, this is dia 10, right? If I am using dia 8, dia 16, will the density change?
Of course, it will change.
Density changes according to what? Huh?
Changes according to
The
volume.
volume.
Area.
So that means the density of the wood of this table will be different than the density of wood of this table because their size are different. The volume are different, right? Why not change? It changes according to what? Why same density? Because it is the same material. Density changes according to material. So if I tell you that dia 10 steel and dia 16 steel are different, then the density will change. Otherwise not. What's my point? Clear? Density does not change according to dia. Dia is a size. Density is a material property. Density is a material property. Okay? So if you take density of cement and you put this cement in a bag and then you take out and put it in a different bag, the density will change? No. Okay? Mass per unit volume will not change. Clear or not? Clear? Okay. So, yeah. So what we did here is very exact calculations. Okay? We calculated the, is this weight correct? I'm not sure. So you have the total length multiplied by this. Is this the answer? And how much? How much? 37? How much is this? 13? 1350? This will be 650. No, it's correct.
Right.
Huh?
650.
650 multiplied by 2, yes. 1300, yes. And how much we are getting? 37 point?
Down you are there is 158.
Sorry?
It's not the calculation.
Yeah, it could be, that's what I'm saying. No
It's
problem.
158.
So how much is this now? According to our calculation, how much is this? Okay, now in this calculation, we have taken the hooks as well, right? Okay, we have taken the hooks as well. Now do a little exercise, we do the whole thing again without the hooks. We just consider that it's a plain drain, okay, 4 sides, we don't consider the hooks. Tell me the difference in the weight, percentage, tell me. So with the hooks we are getting this much. How much weight we will get if you don't consider the hooks? And what will be the change in terms of percentage? Like I'm asking you to do it. They invented ChatGPT for you guys. Huh? They keep on saying, and that guy will do it for you. It's the other way around. I'm using you. You have to do it. You guys are using free version or the paid version? ChatGPT, free version or the paid version? Free, right? Free, huh? Free version, right?
It's 32.88.
32.88
Yes.
with everything?
Yes.
Okay, just have to make the change here only.
Yeah, I remove 180.
You remove 180 and the rest of the things are same.
Yes.
So how much we are getting?
32 point.
32 point?
I just
Nine. Okay, and what is the percentage then? How much percentage change from this one? So almost 5. Huh? 12%. Okay, so you can see how important it is that you look into the smallest things as well. Okay. 13. 12 and something. Your grades will be C point something. Okay. So the point was now 12% of steel price is a lot. Steel is not a cheap material. Okay, steel is not a cheap material. So this 12% can become thousands of BDs, depending upon how many beams you have and how many strips you are providing. This is 12% in how many beams? One beam. Do we have a building of one beam? No. So you can imagine this will multiply. Okay. Why? Just because we did not consider these two small things. Okay. And this is for a steel of less dia. Imagine if you make some assumption regarding the main steel. Okay. So the thing which we were discussing earlier, 100 millimeter to 100 millimeter. If you get confused or assume something between them, you can imagine how much will be the changes in price. So this is how your mistake can cost a lot in the project. Okay. This is your cost of one mistake in the project. You have only missed this step only. That's why things are correct. Okay. Now one step will cost 12% error in just one beam. Okay. Then we have the column plan. Okay. The column plan tells you where are the columns, what are the sizes of the columns. Okay. So you have made columns, right? You have made columns. Okay. Where are the columns here? They are shown by what? Is this a column? No. Is this a column?
Yes.
Yes. Is this a column? No. What is it? It's a footing. So where is the column? Yeah. Okay. The black square in this case is the column. Okay. So it tells you where are the columns, how many are the columns, what is the size of the column, and you can include the footings as well. And again, with each column you can see the numbers. C1, C2. Okay. So what do we do with these numbers? What do we do with these names? Same as beams. I told you, right? What do we do? Sizes and anything else? Huh?
Type.
Type of
Cement.
cement? No. What do we do with the C1, C2? Why do we need to put it C1, C2, C3?
So we can.
They are columns, okay. You can see they are columns, right? Why do I need to give them names?
Because they're different.
They are different how? All of them are squares.
Different sizes, different.
Maybe they are the same size. Okay, what else?
Densities.
Different
Different densities.
density, why?
Maybe they have something extra.
Maybe they have something extra. Okay, what else? Size you can see from here as well. I don't need to put a code here for the size. What else? I told you for the beams.
Much easy to recognize.
Recognize what?
Different.
What I am trying, description. We will prepare a column schedule as well. Like I showed you the beam schedule. Something like this. Okay. So this beam schedule or the column schedule, so you go to the column plan C1. You go to the schedule, C. The size of C1, the reinforcement in C1, maybe if there's a change in quality of concrete as well. Okay, so labeling is important so that later on you can give the details. Labeling is done to get the details later on. Okay, now you see the section here. Section of a beam. Is this section for all the beams? No, this is for a specific beam. Which beam? You can write here B1, B2, B3. Okay. Will it remain the same for all the beams? No. Will you make these sections for all the beams? No. Okay. All B1 beams are like this. Get my point? All B1 beams are like this. Okay. So if there's a column here which says C1, okay, and you see a section somewhere or a table somewhere which shows C1, okay, so now you come here and you see this is C1, this is C1, this is C1, all three of them are same, so that one drawing is enough for three of them, right? Got it? Okay, or that one row of information is enough for all these three C1s. How many C1s we have here? How many? 3? Because I said 3. You have to use your brain. Don't rely on me. 5. Okay. So I don't need 5 sections. I need one section. Okay. But without this naming, you have to do it for all 5 of them, right? For all of them. Okay. Column details. So again, see the cross sections. You can see the bars we are using. You can see the arrangement of the bars. Okay. So it's not straightforward like a beam. Okay, it's not straightforward like a beam. There's 2 on the top, 3 at the bottom. No, you can see the bar arrangement is very different. Okay, what is this? Stirrup. Okay, how many stirrups? Huh? 1. How many? 2. How do we know? How do we know they are 1 or 2 or 3? From? Huh? From the size? From the hooks. How many hooks you have? Every stirrup will have a hook. Every set of stirrups will have a hook. Okay, so how many hooks you have? 1 here and here. Okay, you see more hooks than, that means that it could be more. Okay, obviously it's not so straightforward. You need some information about the construction process as well. But hooks are the most obvious indicators, okay? And you can see the hooks are not the same. This is different than this one. Because this is at the corner, this is in the middle, okay? They are different. Okay, so you see the cross sections here of the columns, and this is the, what do you call? Longitude. It's not like, yeah, it's a longitudinal section, but it will show you the height of the column, the height. Okay, and then you can see the connection with the footing as well. Okay, then we have the slab plan. Okay, the slab plan you can tell you how much concrete you need for the slab. Okay, it gives you the size of the slab. Okay, and then you can have the cross sections as well. You can cut a cross section to see the reinforcement, to see the connections. Okay, to see the depth of the slab. Okay, what else? Yeah, slabs can be cast in situ or they can be precast. Okay, cast in situ normally is done for the bridges now, I believe. For the building projects now they bring precast. So cast in situ means that the concrete is prepared, the concrete is poured on the site for the slab. Okay, now we have ready mixed concrete, so they will mix. You have seen the mixers, right? The mixers on the road. Okay, so while they are moving, the concrete is mixed at the back. So they reach the site, they will pour the concrete. This is cast in situ. Okay, C2 is like on the site. Okay, so you are pouring the concrete on the site. Precast means they will bring the slab on the site. Slab is cast somewhere else, in the factory or somewhere. Okay, so now they are not bringing the concrete, they are bringing the slab. Got it? Okay, and then they make the connections and so on. Okay, they do the finishing. Yes, but the main slab is brought. Okay. So you have to mention this with the drawing as well, whether it is cast in situ or precast. Okay, and if it is cast in situ, then what you are bringing on the site? What is the thing which will come to the site? Huh? Mixer. No, like mixer will bring what? Concrete is different. They are bringing concrete. Okay, they are bringing concrete. Or even if you hired a contractor and he is mixing the cement on the site, it can happen. You can do mixing on the site as well. Okay, on-site mixers are there. So again, you have to bring the cement and sand and aggregate everything, right? Okay. So now your quantity or price is for the concrete. If it is this one. If it is cast in situ, the contractor is charging you for concrete, the material, okay, and the steel. Obviously, if you are using steel, he will charge you for steel. Okay. So if somebody says I have a 20 by 20 meter slab and it is cast in situ, you will calculate the price for concrete and steel. Got it? Clear? Okay. If it is slab which is precast, okay, if it is precast, so what are you bringing to the site now?
Slab.
The slab. Okay, then normally companies charge according to area of the slab. Okay, how much concrete, how much cement, how much sand, how much steel, not my concern. Okay, they will tell me, okay, you need a 400 square meter slab. Okay, my payment is 1000 BD per square meter. Clear? Okay. So you can see, because of the construction method, your pricing system is changing now. Your BOQ entry will change. Okay. For this one, the BOQ entry will look like what we have seen in the previous lecture. It will look like this, the first item. Okay. For the second case, your BOQ entry will look something like this, the last row only. Okay. Supply and fixing of the slab. What is the area of the slab? The units and rate per unit area. So the entire, is the item changed? In both cases, am I doing something? Am I doing a different item? Both of them are slabs, right? It's not like this one is column and this one is beam, or this one is concrete and this one is excavation. It's not like this, right? Both of them are slabs. Both of them are made of concrete. Both of them have steel and maybe the same. The size is same, the type of concrete is same, the type of steel is same. Everything is same. But what did you change? The construction method. Okay, and it can change the price and it can change your whole BOQ. Get my point? Clear? Clear? Okay. And then we have the staircase as well. Somebody mentioned in one of the previous lectures. It's not, I was asking about something related to finishing. So staircase is not finishing. It's the actual structure. It's the main structure. Okay. So you can see it has a reinforced wall. It has a slab. This is what we call as a waste slab. Okay. This is what we call as the landing slab. Okay. So we have the landing slab here, the landing slab here. Two slabs, right? One at the start, one at the end. Okay. So these are two slabs. You can see the concrete. You can see the steel inside it. Okay. And this is where you have the steps, and this is what we call as waste slab. Okay, and you can see here there is steel here as well. Clear? Okay, so you see a cross section like this. It can give you the thickness of the slab. It will give you the reinforcement. Okay, and you can see the reinforcement is in both directions, same as normal slab. Okay. And then you have the beams as well. Okay, so this is the beam here, this is the beam here. Okay, and depending upon what you have here, it could be a column, it could be a beam. But under the slab, there's a beam. Under the landing slab, there's a beam. Okay, this is very common. For supporting the waste slab, so this is the waste slab, right? Okay, this is supported by what? This is connected to what? The landing. Okay. Very rarely you will see columns under this or beams under this. Okay, because it will take your area. Okay, so we don't do that. It will put extra load and you have to connect it to the footing and so on and so forth. Okay, so a staircase has three main items: landing, start and end. It has a base slab. Okay, and then it has the steps. Okay, steps normally don't have any reinforcement or nothing. They are just made up of concrete and you just use them. Okay, and the load goes on to the waste slab. Okay, each step has two parts. Each step has two parts. One is called the tread, the other one is called the riser. This is the tread, this is the riser. Okay, and the standard size of the step is 30 centimeter. Okay, according to some big foot, I don't know. And standard height of the riser is 15 centimeter. Okay, for comfortable walking. Okay, and what else? Concrete is measured in volume, so all the concrete for all these items, steps, landing, waste, everything, concrete will be in volume. It could be the same quantity, quality. Could be the same quality, and steel is measured in weight, like we have seen for stirrups. And all steel details are mentioned in these things. One more thing which you can see is all steel bars are given center to center spacing. Okay, you will see the same thing for footing as well. You will see the same thing for roof slab as well. So in slabs, reinforcement is given with the spacing. So how will you calculate the length? You will take the length of 1 and then multiply with the number. How do you calculate the number? There. Okay, anyway, that one, right? How do you calculate the number? Like this. Okay, so wherever you see spacing, take the length of 1 bar and multiply with the number. How do you calculate the number? Like this. Clear? Clear? Okay. Yeah. In some cases, the beams and columns and the beams and columns are not made up of concrete. Beams and columns can be made up of steel as well. Okay. You have seen, not in bearing. You have seen footbridges made up of steel. Now here we have concrete. Even footbridges are made up of concrete. Are there footbridges of steel here? No. But in many other countries, they make them with steel. Here, I believe because of the temperature. Make it of steel like Uh, you will have a soup every time you go out, right? Okay. Anyways, so footbridges of steel are very common. Okay, you have taken other courses where they have taught you trusses, right? So trusses are made up of steel. All members of trusses are made up of steel. So the beams are made up of steel, the columns are made up of steel. Okay, even the slab is made up of steel as well. Okay, so the good thing about steel members is they are like this. Okay, one material from top to bottom. So our calculations become easy. Later on, if you reach to 400 level, people don't know how to calculate the area of a circle. If you reach to 400 level, you will do that. Okay, then you will have a course of steel design, and they have a steel manual, a very thick manual. Okay, and the good thing about this manual, it gives you the weight per unit of all the cross sections of steel. So if you tell me I'm using an I section, okay, so it has a standard size of I section, so I don't have to think. Okay, I'm using an I section, I will open the manual, this size of the I section. What is the weight? This much is the weight. Done. Just multiply with the length. Okay, so it becomes easier. Okay, steel calculations are then easier. Okay, now what is this? The thing which I was mentioning earlier. Okay, the size of the rebar, the size of the bar, a steel bar, and a weight per unit length in pound per feet and kilogram per meters, if depending upon which unit system you are using. The diameter. Okay, so the diameter is mentioned here. Okay, but it is just to show you what it actually means. Okay, what it actually means. For example, especially if you are looking at books in which there are lots of examples, but the units are used as US system. So in US system, they don't put millimeters. They give you, yeah, not like the inch, like they give you divisions of the inch. So each inch has 16 divisions. Okay, so they tell you number 16 bar. Number 16 bar means 16 divisions of the inch, which means 1 inch. Okay, and this is what it means in or 16 by 8 of an inch, something like this. But the SI units are very easy because number 50 basically means almost 50 millimeters. Okay, and number 36 means almost 36 millimeters. This is what we did, right? In the example of the strip, what we did, it was 10, dia was 10, right? And we took what, 10 millimeters. Okay, so it becomes easier. So our life is easy because we will be using the SI units. Okay, so for your convenience, they have given the area as well. Okay, so you can, this is like a standard table, you can have it with you. Okay, but if you don't have this, you just need the density of steel. Okay, like what we did here. Clear? This is what I found. Okay, just maybe yesterday or something. You can note it down. I mentioned that we can use different tools, right? And some of these tools are online. This is one of the online tools for calculating the dimensions, the length of steel, the area of the volume of concrete. Okay, and they do it for different types. So you can go there and search for the tool for calculating length of stirrups. Okay, so it will open a new page only for length of stirrups. Then you say, okay, length of main bar in the beams. It will give you another page for main bar in the beams. Okay, so it's a very customized page. The calculations what we were doing here, for that much calculation is enough. Okay, but obviously later on in the next lecture we will see how it is done in a standard way. So there is a standard way of writing these calculations. We will not do this yet. There is a standard way of writing these calculations. Okay. Yeah. So I was telling you that we did the excavation work earlier, right? We calculated the amount of excavation required. We wanted the ground level as 1.5 meters deep. We calculated the average and so on and so forth, right? This is another scenario, okay, where the excavation is done for each footing separately. This is more common for villas and buildings. Each footing is excavated separately. Okay, so you will not do the one level for the entire site. Okay, you will tell me, okay, each I have footings and I want the footing excavation done. Okay, so this is a foundation plan. You can see the size of the footing. Okay, and now we have to calculate the excavation for these footings. Okay, one thing which I forgot to mention here is the depth. Let me see if I have it somewhere. No. Okay, so let us assume the depth is 1 meters. I'm talking about the depth. Okay, so you can see the size here, the depth is not mentioned, right? So let us assume the depth is 1 meters. Okay, so how many footings we have? 6 footings we have. What is the size of all footings same? No, yeah, no. How many types we have? Two? No? This one, right? 1500 by 1500. So this is same as this one. Okay. These were same. So how many types we have? Two? Okay. Number 1. What size? Okay. Yeah. Now 400 is what? What is 400? 1500 by 1500 is the size, right? Area. I understand. Okay. What is 400? Huh? The depth. But I said the depth is 1 meter. For excavation. Okay. So we have the footing. I'm now looking at the cross section. Okay. So this is my excavation. Okay. Here is my footing or the full. Okay. This is my footing. Okay. What is this much? What is this? 1500. And 1500 on the other side as well. Okay. What is 400? Okay, the third dimension, but for the footing. Okay, but I'm calculating footing concrete or excavation. I'm calculating excavation, right? Okay, so I will not consider 400. I'll consider how much I have to go down. Okay, so this is 1 meter. Clear? Clear? Okay, so footing number 1. Area multiply by the height and the number, how many? How many of this type? 4. Okay, second one? 2000 by 2000. 1 times 2. Okay, how much for each one of them and how much is total? Sorry?
Why did you put 400?
Because I'm not calculating concrete. 400 is the size of the concrete inside the excavation. Okay, I'm not calculating concrete now.
9 to the power 6.
Which one? 9 to the power 6. Like this. Okay, and this is what? Cube.
8 million.
Cube, right? Millimeter cube, because we took 1500, but we made a mistake.
Yeah.
Yes. This one. Okay, either we make this one as 1.5, 1.5, 2 and 2. Okay, then what will be this? Because this was in millimeter, this was in meters. So there's a problem. How much is that? How much will be this?
9 meter cube.
Okay. So this is what you have to keep in mind. You will see this concrete is in some units, steel in some other units. Okay. So yes, 2 into 2, 4, 4 into 2, 8, 8 meter. Total 17, right? Clear? Any problem? Any problem? Clear? There is an assumption here. What? Who can tell me the assumption? I made an assumption here. When I was doing these calculations, I made an assumption. What was the assumption? I assumed something. It was related to the previous question. The previous one where we calculated the earthwork, the excavation.
Your benchmark,
Yeah. What is my assumption? Yes.
that's your benchmark from the road level, 1 meter down.
My benchmark is 1 meter down? No.
We assume the 400 as a depth.
No, no. Why are you after 400? Forget about 400. Yes, what is my assumption? What is my assumption? It is related to the benchmark, yes. It is related to the benchmark, but what is it? What am I saying here? Or what am I not saying here?
Whether it's a plus or minus.
Okay, I'm assuming all of them are cut, right? This is one assumption. Another? All of them were how much? What is the cut in all of them?
70.
How much height of the cut in all of them? 1 meter. So what is my assumption? All of them are where?
On the same level.
All are at the same level from the benchmark. The difference in the benchmark, the existing level and the benchmark is the same. Okay, so this, the ground at this foundation, the ground at this foundation, the ground at this foundation, and this one, this one, this one. All of them are at the same level from the benchmark. Okay, otherwise, if this one was already 0.5 meter below, I will not do the excavation for 1 meter, right? Your building will become tilted. Okay, you want in the end the foundation to be at the same level, right? So when I said 1 meter for all of them, I am assuming that all of them, the current ground level, all of them is also same. Clear? Okay. This will take some time, but we will do the ones which we have already done. Okay. Or okay, just do the concrete. Can somebody give me the amount of concrete required for this beam only? Okay. You can see it, right? You can see this. The dimensions. Concrete. How do you calculate the quantity of concrete? Yes. What happened? Something happened? No? Okay. Concrete is calculated as area volume. Okay. So I need volume of concrete. What do we do? Very easy. One beam only. 6,000. 6,000?
Can you zoom that?
Huh?
6,000 multiplied by 300 multiplied by 500.
Yeah, tell me.
6,000 multiplied by 400 multiplied by 500.
Yes. Meter cube? Meter cube?
Yes,
6,000? Meter?
only the millimeter.
Millimeter cube, right? It will be millimeter cube. If you want meter cube, then it will be 6 multiplied by
3,
0.3, 0.5. And this will be how much? 3 into 0.3? Huh? 0.9? Sure? There. Okay. Now, again, 6,000 meters, right? 6 meters. 6 meters. Now you can see in the figure 6 meters from where to where. Okay, 6 meters from where to where. So you did not consider what? Something which you can see in the longitudinal section, but you did not consider in this calculation, which was what?
I should add 200 more.
Like you have taken your topics, right? He is after the 400 millimeter and you are after the 25 millimeter, right? The answer to every question is 25 millimeters from height. What did we not consider here? Huh?
The diameter.
No, yes. The column. Okay. You can see the 600, 6,000 is this one. From column face to column face. Okay. Clear? The full beam is actually from here. Okay. In terms of quantity, it can work, no problem. For quantity calculation, it can work. Design of beam will not work like this. Somebody says, do the design of beam and you are saying my beam is this will be wrong. Your beam is from here to here. Okay, this is part of the beam, this is part of the beam. In quantity, it can work, no problem. Okay, I can take a beam from here to here. Okay, but that means what? You have to do something with the column calculations, which is, so now after this, if you calculate the quantity of column, you have to include this one. You cannot ignore this much concrete, right? So your column will not be from here till here and then from here to here. No, your column will be the entire column, no breaks. Got it? Clear or not? Okay. Any questions? So you have to keep these things in mind when you are calculating the quantities. All the points I mentioned. You can see I mentioned the first lecture as well. The calculations are very easy. None of these things are difficult. Okay. If I tell you and you pay attention, it will not take more than 1 second to get these concepts. But the only thing you have to keep in mind is the construction part. How the construction will happen. Okay? Okay? There? We will continue with this. Okay? And I will ask you to do something in the next lecture for which you will need these quantities as well. This one and the previous one. Okay? So write them down somewhere. Some people have already written them down. Take it from here. Okay? You have to prepare something in the next lecture for which you will need the concrete and the foundation, the excavation quantities. Write them down. Have them with you in the next quantities. You calculated the quantity of excavation here, right?
Yes.
And you calculate the quantity of concrete now, right?
Okay.
So have them with you when you come to the next lecture. This is what I'm saying. Calculation you can forget, no problem. Forget about it. You will see it in the exam. Who cares? Okay.